friends, students, and enthusiasts. All right, so one more project in our kitting. The name of the project, which is IoT based, the name of the project is Smart Air Quality Monitoring System using ESP8266. That is nothing but we call it, I also call it as a NodeMCU. So what happens in this, I will just give you, air pollution is the presence of a harmful substance like CO2 and other gases, right? SO2 and other gases are there. And particular matter, that is PM 2.5, that is PM 10 in the atmosphere, right? So major source includes vehicle emission, industrial discharge, burning of fossil fuels, and household activity. These are the main ingredients, or rather which produces or which damages our weather and air quality. So what we really need to do, or what in this project we are going to do. So here need to real-time quality monitoring. That is when you want to really monitor it live on your mobile phone, on your computer. So why it is important? Air quality can vary significantly by location and time. Real-time data helps detect sudden pollution spikes. Timely alert enables individuals and communities to take preventive action. That's why it is very, very important. So preventive action means wearing masks, avoiding outdoor activity. So these are the things what we understand. Okay. So what is the description? I will just give you a little description about the project. This project aimed to create a smart air quality monitoring system using the ESP8266, right? It's an IoT project. So that's why we have used ESP8266 NodeMCU microcontroller. It measures environmental parameters like air quality, temperature, and humidity, and display them locally and remotely via web interface and cloud dashboard. So web on the bottom side, left hand side, you can see it's a live, that is smart air quality monitoring. When you can see on your mobile phone on right hand side, it is your cloud interface, that is ThingSpeak in the form of a this thing gas level or graph. You can see it directly onto that. So both the things are available. Of course, we are using in our project a SSD 1306, a small LCD. On that also will be getting it. So there are 3-4 options. Okay. So we have also used a LED and a buzzer there. Okay. So what are the components used in this? You can just go for it. Microcontroller, NodeMCU, sensor MQ135 for air quality, DST11 temperature and humidity, that is connected to D6. Please remember. And MQ135 is connected to A0, that is analog 0. So humidity sensor D6, display is connected to D1 and D2, that is SDL and SCA pins. Buzzer and LEDs are connected to D7 and D5. Right? And cloud, what we have used? We have used ThingSpeak for remote monitoring. Already we have made a separate video. You can just go and check the video, or there are different videos on the web where you can learn how to do it, or how to load, or how to put, or how to see your parameters on ThingSpeak cloud. Okay. So block diagram, simple. There is a NodeMCU surrounding NodeMCU, DTH11 is connected, MQ135 is connected, then through Wi-Fi. Of course, OLED is also connected through Wi-Fi. It goes to ThingSpeak. Okay, so web server, that is HTML dashboard, that is also through Wi-Fi. You can just see, check it on your computer or your mobile phone. And also you have buzzer and LED alert that we will see when we go to our lab. So alert system is also there. You can see it on the OLED display. You can also check on HTML dashboard, and you can also check it on your ThingSpeak cloud also, right? Okay. Now, description, the system integration sensors with the NodeMCU to collect data, display it locally, and transmit it to the cloud platform. Host a web server for real-time monitoring or a device within the network. Okay, so both the things I've just explained you. So firmware logic and web dashboard contents. Arduino IDE used for programming. So I have used Arduino IDE. Why? Because the program is in C. Libraries are there. First thing you have to remember that I'm going to tell you in the codes part. Code modules, sensor reading, OLED display updates, web server, HTML generation, ThingSpeak data upload. Alert logic, buzzer, and LED. We have already discussed that alert. For alert, we have used both. That is one LED and this thing. We have kept a threshold value also there. The description, the firmware reads sensor data after every 15 seconds, update the OLED triggers, alert if air quality exceeds a threshold, and serves as a dynamic HTML pages. It also upload data to the ThingSpeak for cloud visualization. Okay, so this is our project, what we are going to application. So where we application future scope, what are the future scope or what you can add in this? So application is school, homes, labs, smart cities. Smart city is very popular. School childrens, they can use as a school atmosphere or school environment or school. What is the quality of the air in the school? Labs, smart cities, and all. Environment awareness campaigns can be done where you go outside. Future enhancements are, that means what you can do in you can add GPS for the location tag data. You can also add GPS also. AIML for pollution prediction. That means you have to write a separate small program for AIML. I have already done one program related to this with the AIML. You can check my videos and you can learn from it. Integrate with mobile apps, Blink, Firebase, solar power deployment. So this project promotes environmental awareness and empowers communities with real-time data. It can be scaled for large deployment or integrated into a smart infrastructure system. So for community projects, those students and children who want to do this, it's good for them. So let's go to our lab and check out the things. We are in our lab now. I will just show you what are the connections and how the connection has been given. Okay. So as you can see, on the breadboard, we have arranged everything. That is first on left hand side. This is my gas sensor. This is my gas sensor, right? This is my gas sensor. Temperature, humidity sensor, next BST11. Then I have put buzzer. So this is my buzzer. Display, which is showing temperature right now is 22.90. Humidity is 49%. Air quality is 378. Okay, as you can see, it is showing air quality 378. Okay, right. So this is a NodeMCU ESP8266. This one. Okay, so I have connected a 3.3 volts supply, 3.7 volt supply from a battery. I'm running it on the battery. Already I have loaded the program. That's how I have loaded it that way. So threshold I have given is 530. So how to bring that threshold? This is my gas sensor or environment sensor. What I will do is I have little this thing. I will try to put a gas on this. Let's see what happens if we change the parameter changes or not. Let's see. Okay. So I'm just putting a little gas on it. Let's see if it changes. Yeah, it's changed. Okay. So one this thing, if it goes beyond 530, then as we have already discussed, if it goes beyond 530, what will happen? The buzzer trigger and the LED should come up. Okay, that is our aim. So I'm just putting it on. I will just try to put it from other side so that it will be convenient. So let's see. See, you can see the light has come over here and the buzzer is also coming. Probably you will not be able to hear the buzzer, but the light has come. So unless the temperature goes down, that means, or not the temperature exactly, the air quality. Okay. If the air quality goes down, automatically the buzzer. So this is the indicator. These two are the indicators, that is LED, and these are the indicator. So connection are very simple. I'm going to explain you what are the connection like. So this sensor, that is, it's connected to analog 0 of the pin, that is the first pin on the other side, and D1, D2 are the SCL and SJ connection to this particular these things. So SDL and SCA, this two. Okay, so these are the two connections. So rest of the connections are for buzzer, for this, and for this thing. Okay, so DST is connected to D6. SDL and SCA, I already told you D2 and D1. Buzzer is connected to D7. This buzzer is connected to D7. And LED is connected to D5. So this much only connections are there. Very simple. Okay. Now I will show you how does it look on your mobile app. So that also I'm going to show it to you. So what you have to do is, you will get one IP. When you load the program, you will get an IP address also. So when you get that IP address, you have to open it on your computer or on your mobile phone. Okay, and just check. It will be giving you the complete this thing. Okay, so I will just try to open it. Still the buzzer is coming. Why? Because it is 450, 545. Okay, gas level. So it is giving you the alert. Slowly it will come down. Why? Because the quality will go down gradually. It will not go immediately. It will go gradually. That you have to understand. So, all right. So now you can see here. Here, I'm showing it on my mobile phone. Okay. This is my IP address, what I'm trying to show you. And IP address you can see, and how the temperature and everything is coming on the these things, whether it is status good, bad, or everything. So good, it is coming. Why? Because this thing has stopped. This LED, as you can see, it has stopped. Previously it was coming, now it has stopped. So this is my program, and as you can see, right, I'll try to expand it again. Okay, right. So this is the complete program with this thing. I will share the codes. I will share the details. I will share the PPT also, so that you can try it. This is for all grade of students. What else or what extra you can do, you have already told you in the PPT. So you can certainly try this project at home. This is very good for the community. See, these are the codes, what I'm trying to show you on my screen. So this first, all these things are the libraries. Okay. So one to from here, beginning from here, it starts from here. These are the libraries. So you should have all the libraries. So Wi-Fi, server, DST, wire, and GFX, SSD 1306, ThingSpeak, and Wi-Fi client. Afterwards, you have a Wi-Fi credential. These are the two credentials. Whatever the login ID and passwords are there, you can just put it. Then these are the ThingSpeak credential. If you are just putting it on the cloud, ThingSpeak cloud, you have to fill up this. That is your API key. Your API for this, I have a separate video for this. You can just check my old videos and all, where I have explained you about how you go to ThingSpeak and all, and how you develop the things and all. Okay, so channel ID will be there, API thingspeak.com. This is the web server where it will take this thing. And you have after that BST11, pin D6 and A0 on 135. That is MQ135. Okay. And OLED descriptions are here. It is one is connected to 21 and 22. So buzzer is D7 and LED is D5. Server is 80. Air threshold, this is important. Why? Because this you can change it. So I have given 530 when the buzzer and the light comes on. Okay, so this is the one, and rest of the things. So what you have to change it? Your SSID password and your ThingSpeak. These things you have to change. Okay, please remember this. Change in a sense. Whatever you IDs and password are there, you have to change according to that, and rest will be the same. Okay. So finally, you have to select a board from the tool. Okay, right. I've selected a NodeMCU 12, whatever it is board you are selecting it. We are doing the project with 8266. Okay, COM port naturally. Okay, COM port and this. So after that, just directly load the program. Finally, you will see a Wi-Fi IP address like this, where you will get the web dashboard and where you can check. Of course, on the screen, we have used a SSD screen that is live also you can check.